Alright, welcome back everybody. In this video we're going to look at how we find the line of best fit, find the equation for the line of best fit, using a TI-83 plus series calculator. This works the same basically on the TI-83, TI-83 plus, anything in the TI-84 plus series. Same kind of idea with our keystrokes. So this would apply to any of those. Alright. So here's what we've got. We've got a table of data sitting here, and we're going to find the line of best fit and some other information from this table of data. So the first thing we're going to do on our calculator, excuse me, is we're going to enter the left column of data in L1. So I'm going to pull up my calculator here, and we're going to enter the left column of data in L1. Now in order to get to where we enter L1, we're going to press Stat, which brings us to this screen. Then we're going to pick Edit, and we'll hit Enter, and it'll take us to our data entry screen. And so we're going to enter the numbers from the first column into L1. So I just go ahead and type in 30 and hit Enter, 50 and hit Enter, and 70. 10, 120. Okay, so I have that first column entered into L1. Next thing I'm going to do is I'm going to enter the right column of data into L2. So I can do that right from this screen. I'm just going to use my right arrow to scroll over to L2, and then I'm going to type in the data values: 22, 38, 46, 65, 80, and 85. Okay, so now I have all my data entered into this screen. And by entering them that way, that means that my drop height column here, this column of variables right here, is going to be the x value in my equation. Whatever I enter into L1 is going to be my x value, and whatever I enter into L2 is going to be my y value in my equation. Alright, then I'm going to go back to the main screen. In order to do that, I'm going to hit second mode. It says quit. So I hit second mode, quit, take me back out to my main screen. Now I'm going to press Stat again, and I'm going to go over to the Calc menu for calculation, and I want to choose the number 4. Since we're doing a linear regression, we're going to use the linreg, ax plus b command. So I pick that, and I'm going to hit Enter, and that'll take that linreg command out to the main screen. Then the next thing I want to do is I'm going to press Enter, and my calculator will do my calculations for me. Now notice, when you look at this screen, it tells you the form of the equation, y equals ax plus b, and then gives you the values for a and b. So when I write my equation here, I'm going to write this. I'm going to round these values off. Let's go ahead and we'll round them off to 2 decimal places after the decimal point in order to write our equation. So our equation is going to be y equals 0.71 x, because it's y equals ax plus b, and then b rounds off to 0.50. And so that is our equation for our line of best fit for this data set. Alright, notice how we just substitute the numbers into the template that's given to us on the screen, the y equals ax plus b. Now there's something missing from this linreg data that I might be interested in. Sometimes we're asked to find the value of r, the correlation coefficient. The correlation coefficient measures, how closely the two variables are to, representing a line, a straight line of data. If I need the correlation coefficient and it doesn't show up when I do my regression, there's a command that I can hit on my calculator that will bring up the correlation coefficient In order to get that command, we're going to go to our catalog, which we'll get to by pressing second 0, and we want to find the diagnostic on command. If I find the green D on the keyboard here, which is right below the math key, if I press that key, it'll jump right to the D's so that I don't have to scroll all the way down through the A, B's, and C's. And you'll quickly find the diagnostic on command. If I hit enter, bring that out to my main screen, it's going to turn it so that my calculator returns the diagnostic values when I do my linreg. So I'm going to do that diagnostic on, and now I'm going to do my linreg again, and this time we'll get a little bit more information. We'll get not just the values of A and B, but the values of R squared and R. R squared is exactly what it sounds like. You take the value of R and square it. But what we're interested in here is the R value, the correlation coefficient, and that I typically write my correlation coefficient to 3 decimal places. It's going to be R equals 0.996. That's very, very close to 1, which means that these two variables are related in an almost perfect linear fashion. All right, let's go on and we'll do one more example of finding the line of best fit on the calculator and use that line of best fit. All right, so we've got a data table here that shows the U.S. average annual consumption of bottled water in gallons per person from 1996 to 2004, where the year is given as the number of years since 1996. So this represents the year 1996. Oops, I changed color there somehow. And each year represents 1996 plus that year value. So this last number here is 1996 plus 8. That's the year 2004. We do that sometimes, adjust especially big numbers like years, so that we don't have to type in all those numbers into our calculator. We can just use a single digit number instead of having to type 1996, 1997, etc., etc. So let's go through the process again here. We're going to go back to our stat screen and pick edit, and we're going to go over to our left column and we'll type in the values. Now I have more values this time than I did last time, so I can just write over those. If you have less values than you did the previous time, you can always type in what you need and then delete any extra values that appeared from your previous problem. 13.4. Frenziedly typing. And one thing you want to make sure when you do this from a quality control standpoint, and to make sure your answers are correct, make sure after you type each number in that you didn't make a typo, because that's one of the biggest problems that lead to inaccuracies in our lines of best fit, is that we accidentally type in the wrong number. But all my number values are good, so now I'm going to go back out to the main screen, and I'm going to choose, go back to Stat, Calc, go down to linreg, pick that command, run the linear regression. And this time I got the R squared and R values right away because I already turned the diagnostics on. Once you've turned the diagnostics on one time on your calculator, they should be on, unless you reset your calculator or someone turns them off. Alright, so now I'm going to write my line of best fit. Again, I'm going to round my A and B to 2 decimal places. So we're going to have y equals 1.36x plus 11.87. And that's going to be our line of best fit. And my correlation coefficient, I can read right from that screen. I'm going to round that to 3 decimal places. It's 0.995. Again, that means that our data set has a nearly perfect linear relationship. And in this last question, we're going to do something that we haven't done yet, and that's use our equation for predictive purposes. we're going to use it to predict the number of gallons of bottled water that were consumed in the year 2010. So in order to do that, realize, again, year stands for X in our equation. So we're going to put the year 2010 into this equation for X. And that'll give us the number of gallons of water, which is the value of Y. Now when we do this, we've got to figure out, because we adjusted the years that we entered into our data set, we've got to figure out what year is 2010. And so if 2004 was 8, 2010 is 6 years later. So that's actually going to be year 14, according to the way we've set up our years. So now, in order to use the equation to predict the number of gallons of bottled water consumed in 2010, we're just going to take 14 and substitute it into this equation for X. And then we're going to do the appropriate calculations. So we've got 1.36 times 14 plus 11.87. And we get 30.91 for our value of Y. And to answer this question, I'm going to round this value that I calculated. I'm going to round it off so that it has the same number of decimal digits as the gallons did in my table. I'm going to round it off to the nearest 1 decimal place. And so my answer to this question would be that I'm predicting that 30.9 gallons were drank or consumed in the year 2010. Alright, that's the end of this video, the end of this particular section, and in fact the end of Unit 6. Congratulations folks, you're getting close. Alright, see you guys next time. Have a great rest of your day.